Ever wonder how Google Maps instantly finds the fastest route to your coffee shop? Or how Netflix knows exactly what movie you'll love next, sometimes even before you do? It's not magic, and it's way more than just clever programming. We often think of data as simple lists or tables, neatly organized rows and columns, like a spreadsheet. But that's just the surface. The real power, the true secret behind so much of the modern world, comes from understanding how everything is connected. What we need to understand is that the digital universe isn't flat. It's a vast, intricate web of relationships. And today, we're going to uncover the invisible architecture that powers everything from your social life to global logistics. We're talking about graphs, the data structure that secretly connects your entire life, and how powerful companies use them to shape your world. Let's break this down. Imagine your city. Every building, every park, every bus stop is a specific place, right? In the world of graphs, we call these places nodes. Think of them as individual points of interest. Now, how do you get from one building to another? You use roads, paths, or maybe even a bridge. These connections between places are what we call edges in a graph. So, a graph is simply a collection of these points, the nodes, and the lines that connect them, the edges. It's really that simple. A person on social media is a node. Their friendship with another person? That's an edge. A website on the internet? Node. The hyperlink that takes you to another page? Edge. What makes graphs so incredibly powerful isn't the individual nodes or edges themselves, but the network they form. We can represent almost anything with this simple model. The number of nodes and edges can become astronomical, but the fundamental concept remains the same. And here's where it gets interesting. Not all connections are created equal. Just like some roads are two-way streets and others are one-way, graphs have different types too. First, we have undirected graphs. This is like a two-way street. If I'm friends with you on social media, you're automatically friends with me. The connection goes both ways. There's no specific direction. Then, we have directed graphs. Think of this as a one-way street. On platforms like X, formerly Twitter, you can follow someone, but they don't have to follow you back. The connection, or the edge, has a specific direction. It goes from you to them. These directed graphs are crucial for understanding flows, like how information spreads, or how data moves through a network. Sometimes, these connections also have a weight, like the distance of a road, or the strength of a friendship. This weight can change how we prioritize paths, making some connections more important than others. While priority_q is not empty. Current_distance, current_node equals extract_min, priority_q. If current_distance distances, current_node. Continue. For neighbor in graph.neighbors, current_node. Weight equals graph.edge_weight, current_node, neighbor. New_path_distance equals current_distance plus weight. If new_path_distance distances, neighbor. Distances, neighbor, equals new_path_distance. Add underscore to underscore priority_q, new_path_distance, neighbor. Return distances, end_node. But the genius part is this: once we have all these nodes and edges, we can ask them questions. Big questions. Like, what's the absolute fastest way to get from point A to point B? This is where graph algorithms step in. You've probably heard of algorithms like Dijkstra's or breadth-first search. They might sound complex, but at their core, they're just super efficient ways to explore a graph and find the best path. Imagine you're trying to navigate a huge maze. You wouldn't just wander aimlessly. You'd have a strategy. These algorithms are those strategies. They systematically check connections, weighing options, until they find the optimal route. It's like asking a super smart friend for directions, but this friend can process millions of roads and traffic conditions in milliseconds. This ability to find paths isn't just for navigation, it's fundamental to how data flows on the internet, how tasks are scheduled, and even how diseases spread. Now, let's talk about something incredibly personal, your social life. Social media platforms, for instance, are massive, complex graphs. Every single user is a node. Every friendship, every follow, every like, every share, every comment, these are all edges. When you log onto a platform like Instagram or Facebook, you're essentially interacting with a giant, dynamic graph. This graph isn't just sitting there. It's actively analyzed. Algorithms look at who your friends are friends with, and who you interact with most. This helps them suggest new friends you might know, or show you content from people you're more likely to engage with. They even use graph analysis to identify influencers or detect online communities. It's all about understanding the patterns and strengths of connections within this massive social graph. It's not just showing you posts, it's about predicting what you care about, based on your digital relationships. Let's get practical with one of the most common applications we use every day, Google Maps. How does it work? It builds a massive graph of the real world. Every intersection, every street corner, every landmark is a node. Every road segment connecting them is an edge. These edges aren't just lines, they have weights. The weight could be the actual distance, the average travel time, or even real-time traffic data, making some paths heavier or slower than others. When you punch in your destination, Google Maps performs a super-fast shortest path calculation on this massive graph. It considers all the possible routes, their weights, and finds the one that minimizes travel time or distance. This isn't just for cars either. Think about public transport. Each stop is a node, each train or bus line segment is an edge, and the weight is the travel time between stops, including transfers. This is graph theory in action, guiding billions of journeys daily, seamlessly translating the complex physical world into a traversable data structure. But graphs don't just tell you where to go, they also tell you what to buy, what to watch, and what to read. We're talking about recommendation systems, the silent architects of your consumption habits. Think about Amazon suggesting products or Netflix recommending shows. How do they do it? They build a graph where users are nodes, and products are nodes. An edge exists if a user bought, viewed, or liked a product. By analyzing these connections, the system can find patterns. For example, it might see that users who bought product A also frequently bought product B. This creates an implicit edge between products A and B. Or it might find other users who have similar tastes to you and recommend what they liked. It's like having a digital personal shopper who knows the entire store and all its customers, and can make incredibly accurate predictions based on millions of hidden connections. This is how these platforms keep you engaged, constantly suggesting the next thing you'll love, all thanks to the power of graphs. Equals 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 equals. Final segment, close and summary, 1530 to 1700 hours. Equals 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 equals. So, from the moment you wake up and check your social media feed, to navigating your commute, and winding down with a recommended movie, graph data structures are silently at work, connecting the dots of your digital and physical world. They transform discrete pieces of information into an interconnected tapestry, revealing hidden patterns and allowing us to solve incredibly complex problems with elegant simplicity. We've seen how they model friendships, find the fastest routes, and power the AI behind your favorite streaming services. Understanding graphs isn't just for software engineers, it's about understanding the very fabric of our connected existence. It's about recognizing the hidden architecture that drives so much of modern technology. If you like diving into how everything is connected through graphs, wait until you see how trees organize information efficiently, making search and retrieval lightning fast. That's what we'll be exploring in our next episode. Make sure you subscribe so you don't miss it.